Hi everyone, Sal Khan here. Welcome to Homeroom with Sal. We have a very exciting show today after a bit of a hiatus. We haven't done a live stream in a little while, but we have Vas Narasimhan, who is the CEO of Novartis. We had him on last year at the early phases of the pandemic, and so you can imagine there's a lot to talk about there, but also just generally about medical science and running a large multinational organization. So if you have questions, start thinking of them, put them in the message boards on Facebook or YouTube or wherever you happen to be watching this live stream. But before we jump into it with Vas, I will make my standard announcements. First of all, I want to remind everyone we are not for profit. We can only exist with philanthropic donations. So if you are in a position to do so, please think about going to khanacademy.org/donate, and donations of all size make a big difference for our mission of trying to educate the world. I also want to make a special shout out to a whole series of organizations that stepped up when they realized that Khan Academy's expenses only went up when the world started to depend on it even more during the global school closures. So special thanks to Bank of America, AT&T, Google.org, Novartis, Fastly, and General Motors. And then last but not least, I want to remind folks that there is a podcast version of this live stream, Homeroom with Sal, the podcast, wherever you get your podcasts. So with that, I am super excited to welcome back Vas Narasimhan back to our live stream. And, you know, in full disclosure, y'all are one of our sponsors, so thank you also. And you know, people should also know I'm somewhat biased towards you and Novartis, so take everything we say with a grain of salt. But welcome back, Vas.
Great to be here, Sal. And I've even put on my kids gave me a Khan Academy sticker to really be part of the cause. So we're thrilled to support Khan Academy. I think it's amazing what all of you do, and look forward to the discussions.
You know, I'm both heartened and disappointed by what you just said. I'm heartened that you're wearing a Khan Academy sticker. I'm disappointed that your kids had to force you to wear that. I'd like to think that in your day-to-day management of running, you know, one of the largest pharma companies in the world, you wear a Khan Academy sticker. But maybe that will change.
I'll take that on advisement, Sal. I'll take it on advisement.
Well, you know, maybe a good place to start. And I actually have a question. Obviously, we're in, I guess, I don't know what we call it, year 2 now of COVID-19. Some people are saying it should be called COVID-20 now with the Delta variant. And I've heard this word syndemic. And I'm hearing it actually in kind of pharma medical circles. My wife's a doctor as well. What is a syndemic?
A syndemic is the term we use kind of for a parallel epidemic that's happening alongside the pandemic. I mean, what we saw throughout last year is, unfortunately, as COVID took hold across healthcare systems, that patients didn't get the routine care they need for things like cancer, cardiovascular disease, lung disease, a range of different diseases. Part of that were patients were afraid to go to the hospital. A big part of that were hospitals were just so busy caring for COVID patients. And what that leads to is when patients aren't getting their normal care for non-communicable diseases like heart disease or cancer, those diseases get worse. And actually, it's even harder to treat those patients later on. Now, we saw that improve in the first part of this year as it looked like things were getting better. Unfortunately, now as Delta variant kind of takes hold again, we're seeing it again be an issue. I'm hopeful that healthcare systems can figure out a way to continue to see patients so they get the care they need.
Yeah, I mean, it's a fascinating question because we've talked a lot about school closures and learning loss. And it's one of these things where we as human beings will obviously watch the news and we'll see people who are, you know, getting hospitalized and intubated or worse because of the pandemic. So that feels very urgent. And then a lot of what we try to do at Khan Academy is remind folks, well, you know, there's also side effects of kids not being in school. In fact, long-term, they could be even larger side effects, more harm to more kids than even the pandemic itself. And what you're bringing up is, even though our healthcare system is operating and doing incredible things, when the pandemic picks up, and especially once ICUs fill up or people are afraid to go to the hospital, it's creating a bit of a health loss, a health debt, which my wife has also described. Like, she just started, now that she's seeing more patients in person, she's seeing how many of her patients have really degraded in the time that they were afraid or they couldn't come to the hospital. How does Novartis, you know, before we started recording, I actually didn't fully appreciate, you know, a lot of people when they talk about the vaccines, they're talking about Pfizer, Moderna, and J&J, but I didn't realize that y'all were actually one of the larger producers of vaccines. But above and beyond, I'm curious how that's been going, but above and beyond that, when you're running a large, one of the largest pharma companies in the world, I believe the largest producer of pharmaceuticals, what is the pandemic or the syndemic? Has that changed what y'all are doing, and does it change how you think about what your goals as an organization?
It's had a lot of different impacts. Just to give your listeners a sense of scope, I mean, so we are about 110,000 people, operate in 150 countries. We produce about 70 billion doses of medicine a year, and in a usual year, we reach about 800 million patients with those medicines. So a very, very large scale. Now, of course, when you have something like this disrupt healthcare systems, it impacts our business, also impacts our ability to run clinical trials. Many of our clinical trials were disrupted. We've had to do a lot of work to keep clinical trials and clinical research going at an appropriate pace. One of the other challenges that we see from a clinical standpoint is, I'm sure your wife is seeing this as well, if you see cancer patients who are treated later, usually the medicines have a harder and harder time having their effect if patients are more progressed, similarly in heart disease or lung disease. So we're trying to educate policymakers. I think health ministers that I speak with are very aware of this challenge, but it is a very human challenge. In the end, people can get very afraid to go to the hospital, and they put off routine care or very routine screening in the case of many of these diseases. Now, you also asked about vaccine production. I mean, our part, I think, is small relative to many of the companies that are the innovators of these vaccines. But given our very large manufacturing footprint, we are able to produce vaccines here in Switzerland and our facilities in Austria to support, the global pandemic. And it's something I think we feel like is part of our responsibility, as a large healthcare company.
I never thought about it. I mean, we were talking about the syndemic just now and how other types of things could be slowed down or there could be a health debt, but I never thought about the impact on clinical trials themselves. Do you think industry-wide this is actually slowing down some drugs that could have gone to market sooner?
I mean, I think it remains to be seen. I mean, companies have been working really hard. Like, for instance, one of the big transitions we've seen is just to use technology to keep people on clinical trials. So clinical trials used to be a very human heavy endeavor, and now we're using remote monitoring to monitor the patients on our clinical trials, keep them on study. But I do think you'll see some impacts for sure. I mean, if you just think about the disruption, a clinical trial anyway is such a hard thing to run. If suddenly like an entire country says no patients can come into the hospital, and then suddenly that country is shut down for your clinical trial, then you have to go to another country. These creates disruptions in your data sets. And then when you run the statistics that many people learn about through Khan Academy, those statistics get harder to run because you have to account for all of these disruptions that have happened in the studies. I would say, though, overall, at least we've been able to manage, reasonably well.
Yeah, no, it's fascinating. And I will, as an aside, give you full credit. You are the best guest when it comes to plugging Khan Academy. Beyond the sticker on your shirt. If you mention statistics, you remind everyone it can be learned on Khan Academy. So special,
my son just completed the statistics course on Khan Academy, so that's why I knew about the statistics. I was getting my own refresher on some of these topics.
I think I'm going to send you another sticker, Vas. You deserve it. Well, I mean, getting to more serious topics, which I unfortunately took us on a tangent. The vaccines itself, they're, thank God, thank the universe that we now have them. Obviously, it's somewhat been politicized, where not everyone is taking them. But what's your view of how this is going to play out? Obviously, I remember last year I was watching some news channel and there was some epidemiologist who seemed like doom and gloom, who's like, we're never, this thing's always going to be here. It's going to be like the flu. It's going to be constantly evolving. We're just going to have to live with COVID in the future. And I remember at the time, everyone, I think, thought that guy was a wet blanket. Like, it's not going to be that way. Now it's starting to feel like that guy might have been right. Obviously, you have the Delta variant. People are talking about booster shots. People are talking about, do we need a Delta aware vaccine? What's your view of all of this? Are people working on a Delta aware vaccine? Is this going to constantly evolve? Will there be a Gamma and an Omega, a COVID-21? Well, how do you think this is going to happen?
Yeah, so a few big principal points I think it's worth for the listeners to understand. I mean, one, we're surrounded by viruses. I mean, if you think like a cup of seawater, you have billions or trillions of viruses, and viruses actually probably enabled the first prokaryotic and eukaryotic cells, maybe even multicellular life. So we live with viruses. And then when you look at coronaviruses, there are 4 normally circulating coronaviruses that cause the common cold, alongside many other viruses that we deal with as the human species and that we've adapted to. So usually with these types of respiratory viruses, the expectation is eventually we will reach an equilibrium state where the virus evolves to a place where it is causing minimally symptomatic disease, but enabling spread. Think about the common cold, runny nose, all of those things. And our immune systems get primed enough that we can handle that assault because we have memory in our T cells. We also have memory in our B cells. And we're able to deal with, like as we do with other coronaviruses. What we're observing right now is that process happening. And the virus is mutating, our immune systems are developing, vaccines are hopefully enabling our immune systems to get stronger, they clearly are, and then are enabling us to adapt. And the question is, how can we, as a global society, best manage that to minimize the impact as we get to that equilibrium? So that's kind of the way I think about the big picture. It's hard to know when exactly that equilibrium will happen, but it will. But I think it's reasonable to expect that this coronavirus will become a normal circulating coronavirus like we have other coronaviruses, and cause symptomatic respiratory illness, but probably nothing severe because we've adapted to it as a species. Now, in the meantime, the question is, how much do we need to keep working on future vaccines? And I think it's an open question. I think we have to be driven by data. The data would seem to suggest that the current vaccines produce a very robust memory response. It also seems naturally infected people are producing a memory response. That's why we see less severe disease and less hospitalizations and deaths in people who are previously vaccinated. But people who are previously vaccinated are able to get infected and spread. And so we're going to have to see, I think, in the coming months how the data plays out, how the booster shots really look from a data standpoint. And I think the health authorities then will figure out what the right path forward is. But I think it's worth remembering that this is going to be an equilibrium that happens over time. Also, I think it's an incredible accomplishment of modern science that by the end of this year, my guess is we'll have over 10 billion doses of vaccine produced, which is really less than 18, 20 months from when we first characterized this virus. That's an astonishing scientific achievement.
No, it is incredible. And, just following on this notion that vaccines are constantly evolving. I mean, I redid a Khan Academy video yesterday about evolution and natural selection. And I know sometimes people say, oh, well, this goes over, it's something that you don't necessarily see. It occurs over millions of years. I'm like, no, you're seeing it before your eyes with these variants of these viruses. And you're seeing it every year with the flu virus. Evolution is happening. And to your point, selection pressure for a virus, it wouldn't naturally select for viruses that are necessarily more deadly. It's actually not in the virus's interest to kill the host. Now, I think everyone's nightmare scenarios are something that spreads like Delta. It's very easy to spread. It can kind of evade at least the first phases of the immune system, and then kind of stays dormant while it spreads, and then becomes worse, and then becomes deadly. Is it just kind of dark science fiction thinking that we could go in that direction? Because I guess the argument is evolution wouldn't select for something like that. It could randomly happen because we have so many hosts right now, billions of hosts, each with billions of viruses in them, that is maybe accelerating the evolution to some degree.
Yeah, I think it's, certainly all possible, but in general, what we do observe in viruses, and again, if you look at parainfluenza viruses and rhinoviruses and other coronaviruses, the tropism and the way they tend to evolve is to be minimally symptomatic and very transmissible, because they actually want you to move around and behave normally, because that's how the gene, as you likely taught in the natural selection class, will then pass on to the next generation, and the viruses will propagate. If you look at other examples, things like some of the hemorrhagic fevers that come out of Africa, whether it's Ebola, Marburg, Lassa, they have very high case fatality rates, but they usually burn out because eventually they kill the host so fast that transmission doesn't happen, and those tend to be very contained. So that is what the history would tell us and how you would expect for this to play out. I think even if you had a very, more virulent strain, again, the human immune system is designed to, especially for these kinds of respiratory viruses, to develop a very robust immune response. But what you invariably have when you have that happen is you will have a bump in severe cases, when such a virus comes about. But I overall still remain optimistic. I mean, when I look at these kinds of respiratory viruses and how, in a big picture view, how they tend to settle in human populations, they tend to trend towards an equilibrium state of minimally symptomatic or mildly symptomatic cold-like respiratory condition. Then we wouldn't even notice, and we would just say, oh, it's just another circulating cold virus.
Right. And we have historical examples of that. The flu, obviously, at one point, the flu was scary, very scary. It's still not completely not scary, but it's much more maintainable. A big question, and it connects with what we often talk about, education, is, vaccines for younger people. What's your view of why it is taking longer, and what we might expect to see in the next few months when we might be able to vaccinate 12 and under? And I am also curious, I've had a very US specific view on that. What are other countries doing on the vaccination of younger people?
So first, I think it's, again, worth looking at how astonishing the achievement of pediatric vaccination has been. I mean, if you look actually back over the last century, the biggest public health intervention, along with clean water, that's happened in human history is actually pediatric vaccination. I mean, it's astonishing what pediatric vaccination has been able to accomplish. And we often forget that because we just don't see mumps and measles and rubella and all of these conditions any longer. Pneumococcal pneumonia, meningococcal meningitis, because these vaccines have been so effective. And so one, I think it's worth reminding ourselves that when we do get a pediatric vaccine approved, people should really look to vaccinate children. It's one of the most successful public health interventions that we've ever had. Now, in terms of usually how vaccines are developed, and including drugs as well, is we step down through the age groups because we want to ensure that there's a good safety profile, because children's immune systems, you of course want to ensure that you're not going to have any adverse consequences. And so I think that's what's being systematically done. Usually, historically, what you do is you get down to 11-year-olds, then 2 to 10-year-olds, and then under 2 years old. And again, it's worth remembering that most children in the world get a lot of vaccines when they're 2 months of age. That's actually when we start vaccinating. So we'll see how the data develops on that front, but my guess is over time we'll be getting down in those younger and younger age groups. I think many countries around the world are similar to the US now at the 12 plus age range. And then I think over the coming months we'll be able to get into the pediatric age range and then younger as well.
And does it change depending on what? I'm assuming there's certain safety profiles. You have to test the vaccine in a certain scale normally, but when you're in something of a public health emergency like this, do they change the rules, or do they just try to run the trials faster? How do they expedite things?
Well, first, I would say these vaccines have the biggest safety databases of maybe any vaccines right now. I mean, you have billions of doses, and so the denominators here are remarkable to look at any adverse event. And while I think understandably there is news media pickup whenever there is any sort of event, it's important to recognize that in most cases these are astonishingly rare, and you have more risk getting in your car in the morning than you do of any of these very rare adverse events for vaccines. And it's so very hard, as you know, for the human mind to assess risk. But I think one of the useful things to do is compare it to the other risks you take every single day living your life, and you see that these risks are actually quite small. The way the clinical trials they're using pretty standard clinical trials. And I would say my own experience in vaccines, these numbers are very large that they're using. I mean, most of the databases here in the clinical studies are 50,000 to 100,000 plus patients. Those are very robust databases to identify significant safety signals, including in children. So I would feel very confident that the regulators and the companies are doing the right thing here.
Yeah, and on that last point about stack ranking the things that are dangerous in life, until we have a vaccine for younger kids, at least here in the US, we've heard stories now that school is starting up. pretty scary stories of 10-20% of kindergartners not showing up because parents are afraid of the Delta variant. And it is scary. I have one of my oldest got vaccinated. He's 12, but my other two are not vaccinated. So I definitely feel that. But at the same time, just my own curiosity, I started looking up hospitalizations and deaths, and it does not, even the Delta variant does not seem dramatically different. I might be wrong, or maybe the data hasn't fully come in yet with the flu. And both of them are actually less likely to kill a young person, to your point, than a car or a swimming pool. So for those of you what would be your advice to a parent who's scared right now, especially if they can't get their kids vaccinated?
Yeah, I think again, when you look at the data, it would suggest that, especially in younger children, that the risk here is very small. I mean, even infected children, despite the one-off news media reports that you're hearing, you're seeing very low rates of hospitalization or severe disease. And my guess is it's probably even better than we see in the data, because the denominator of number of children or adults who are asymptomatically infected are not captured is quite significant. And there have been very good models that have been produced by different economists and epidemiologists that would suggest 5, 10, maybe more fold undercounting of the denominator, which means that the actual rate of hospitalization, rate of severe disease, rate of death is even lower than what we might think otherwise. So, I would, if the school is open and the school has appropriate precautions, I think the damage we could be doing to children by not ensuring that they're continuing to have their social development, their educational development, as something we've got to factor into. I mean, one of the things I'm sure you're also concerned about globally, the loss of years of education and the impact that will have on the long-term mental and social well-being for these generations of children is substantial and should be counted, right? And counted and considered whenever we think about school lockdowns and school closures.
Yeah, couldn't agree more. But it's going to be interesting how this plays out. Well, thank you for indulging me and all of us. And I actually give credit to Rainer Rustenberg. They asked a couple of questions that I paraphrased a little bit, so I want to make sure that YouTube viewer gets proper credit for the questions. But I do want to shift a little bit. I could talk for hours about the vaccine and how all of this might evolve. But I also want to be looking post-pandemic, or maybe it's related to the pandemic. I mean, you're running one of the largest pharmaceutical companies in the world. What are you excited about? Where is medicine going? Well, I think medicine, a lot of people compare education to medicine, and they're like, look at what medicine has done in the last 50 years. And education, there's a lot of good in education, but it looks like it's fairly similar to the way it was 50 years ago or 100 years ago. Hopefully some of that will change for the better. But what do you think medicine's going to look like if we fast forward 5 years, 10 years, 20 years?
Yeah, it's interesting. I mean, right now we're undergoing really a substantial renaissance in how we think about therapeutics in medicine. I mean, we go again back in history. It was really in the early 1900s we began to think about medicine as being able to, impact the human body. And before then, we had much less sophisticated views on how to impact health. We started with chemicals, so chemistry, small molecule chemicals that would interact with proteins to try to get a therapeutic effect. Around the 1970s, 1980s, we moved into the world of producing large molecules, so proteins to impact proteins, or proteins to bind other proteins, or proteins to bind other things in the body. That's called biologics. We had small molecules and biologics. And then there wasn't another revolution until pretty recently, where now there's been an explosion of a few different technologies. Some of them we work on, gene therapies, which allow us to edit the genome of patients to really correct for inherited abnormalities. You have cell therapies, which are taking cells out of the body, reprogramming them, using technologies like you've heard of, like CRISPR, that then reprogram the cells, put them back in the body. We have RNA, and maybe everybody knows about mRNA, the other revolution that's happened that was years in the making, going back to work done in the 1970s and 1980s, is to understand how RNA modulates other RNA. And there's technologies called antisense oligonucleotides, or silencing RNAs, which can be used as therapeutics. And those are now getting approved as well. So we're using RNA as therapeutics. These are very small strands of RNA. Now, all of these areas are opening up all of these technologies, I should say, are opening up whole new fields of medicine that we think where we can treat diseases that we haven't been able to treat in the past. When you think about the numbers, rough numbers here, we can treat about 700 of the roughly 8,000 to 10,000 diseases that are in the various compendiums. So there's still a lot of opportunity for us to improve human health, and these technologies are helping us do that. The other big revolution now is data science and AI, which I'm sure you talk about. I know it's impacting education, impacting our industry as well. So how can you use AI to find new drugs, to develop drugs faster, to produce those drugs more efficiently? Probably many people would have seen that Google recently published the structures, or DeepMind published the structures of all proteins that they've been able to identify thus far in a database, which is, again, a massive accomplishment and done through artificial intelligence.
You know, it is mind-boggling, and I mean, I was thinking about asking, but when will we see this? But then I realized we actually are seeing it. It's happening behind the scenes. I mean, even my wife, who's a rheumatologist, she's saying, you know, the medications, the drugs that she has access to, even 20 years ago, they were just maintaining the pain, while now they can actually start to provide therapies and treat. You know, if we go 10, 15 years in the future, are there certain areas that you're particularly hopeful about, or maybe you just don't want to jinx it yet? But, you know, I'm sure there's areas that y'all are investing in that you think that there's space for some innovation.
Yeah, I think a few areas that we have the opportunity. I mean, the goal, of course, is to get to a larger absolute efficacy gain. And can you really get to maybe even cures and remissions? When you look at the whole world of blood cancers, it's astonishing. I mean, the progress we're making. And I'm hopeful that we can get to a world with all of the efforts in the R sector and with academia and government, that maybe nobody needs to die from a blood cancer, given the pace of innovation we're seeing there. It's pretty remarkable. When you look at certain rare diseases, we already have a medicine that, when given to a child early enough, can almost eliminate what would have otherwise have been a certainly terminal disease for these children. And that's with a single injection of that gene therapy. So I think in certain rare diseases, you're going to see astonishing progress. We're big believers in cardiovascular. Still, it's worth remembering the largest cause of death and disability in the world is heart disease, even more than any infection. I haven't checked the numbers. It may still have outdone COVID last year as well in terms of overall death and disability. So I think advances in cardiovascular disease are an opportunity to maybe not have people die from heart attacks or subsequent heart attacks. So those are areas of tremendous opportunity: cardiovascular disease, cancer, et cetera. I mean, the places where we have a lot of work to do is still understanding better the biology of the brain, cognitive disorders, psychiatric disorders, neurodegenerative disorders. The brain is a remarkable feat of billions of years of evolution, but still a lot of work to do to understand what's going on in the diseases of the brain.
Yeah, well, no, it makes me very helpful, very hopeful for where we're going. And I know, you know, whenever I could talk to you literally for hours. Hopefully, we'll get a chance to do that. But I just glanced at the clock. I was like, oh, we're almost out of time. So Vas, you know, I just wanted to thank you incredibly. I have to say it, you know, and I'm not saying this just because Novartis is one of the major supporters of Khan Academy. I think I would say this regardless. But talking to you is incredibly refreshing, because there's a whole CEO part of your job, which, you know, the CEO part of my job, which I try to do vaguely competently, is hard. And we are about 200 folks. You are talking about 100,000 plus employees. And so you must be incredible at that. But just speaking to you on science, the fact how deep you can go and that we can kind of nerd out together, while you're also managing 100,000 plus, you know, major pharmaceutical entity, you know, that's giving drugs to 800 million people. It's kind of mind blowing, but at the same time heartening to see how deep you can go. So thank you and then your willingness to talk to me. Thank you for
I appreciate it. Maybe for any of the students out there, I mean, I'm still a scientist at heart, and I hope I can prove that you can be a scientist and work in the business world, but stay passionate about science and medicine, because what wakes me up every day is those amazing findings that we have that can transform human life. So always grateful to be here and look forward to the next conversation. So.
Yeah, you know, in amongst like actors and stuff, there's the notion of a double threat or a triple threat. If you can act and sing, or, you know, act and sing and dance, you know how to manage and nerd out. Maybe you can act and sing and dance too. We'll talk about that next time.
No, my kids would tell you I cannot act or sing, so that they prefer me to stick with being a CEO.
Excellent, excellent. Well, thank you so much, Vas, and say hi to your
Thank you
kids who
so
I know are Khan Academy users and distributing Khan Academy stickers, which I appreciate.
All right, take care.
All right. Yeah. Well, thanks everyone for joining. I hope you enjoyed that conversation with Vas. And I said it, I meant it. It's actually incredibly refreshing when you meet someone who leads a multinational organization like that, but who can also really go deep and clearly has a passion for what they do and the impact they're having on the planet. So hopefully you found that as inspiring as I did, and I look forward to seeing y'all next time. We are going to have a homeroom. It's going to be with our Chief Learning Officer, Kristen DeCherbo, going to talk to our Head of Content, Adam Green, about all of the new content and course refreshers on Khan Academy. And I don't want to pick favorites because there's a lot of new content, but we've been doing a big science push. That video I just talked about around gene expression and around evolution, that's part of our science push. So keep a lookout for that, but you'll hear much more about it on the Ed Talks with Kristen DeCherbo and Adam tomorrow. So with that, I will see y'all later. Onward.